Welcome to Interactive AL directly in Visual Studio Code. Hey, I'm Eric, and if you followed along on the channel, you would know that I did a couple of weeks back a video on Interactive AL where I took my compiler, AL compiler, and kind of pulled it gently apart so I could emulate or replicate the experience you like on an old Commodore 64, where you type in commands and stuff will do, and you could also program, but you could interact with Business Central through AL. And I, at least in the comments, but also I think in the video, kind of made up some lame excuses why this has to be inside Business Central, and that's all in the past, because now, today, this video, we're in the future, and no more lame excuses, no more saying that stuff is hard, because hey, it was hard. But let me show you where I am today. Tonight, this is very, very late, and it's pitch black outside here in British Columbia. But anyway, let's get to the good stuff. So here is Visual Studio Code, and you can see that I'm in some sort of AL project. It's not important right now, but you can also see down here in the terminal section that I now have an AL terminal inside Visual Studio Code. So I could type, we can get today's date. That's AL. We could create a variable. C could be a record of customer. We could list and see what variables do we have. We have a C variable right now, so let's do a C find first. Got that. Let's see what customer this is. Oh, we can do a C next. How about that? And let's check. Oh, now we're at the next customer. We can do a C find last. And what customer do we have now? Relic Cloud, or perhaps we should change this to YouTube demo. So what is CNAME now? What is CNAME now? It's YouTube demo, and let's modify this. So now we have an open database transaction. So maybe we want to commit this guy. So let's commit this so we don't sit here and talk while we have a transaction open. So you can see over list we can create another variable. I is an integer, or perhaps we want a D for decimal, so I could be 17 and D could be 34, and let's check what variables we have. We have a fully interactive AL experience right here in Visual Studio Code. Magic. Well, it's not magic, but let me show you how this actually works. So what I have here is kind of the exact same thing as you saw inside Business Central in the last video. Hope you saw it. Otherwise, you should totally subscribe to the channel and check out all the cool stuff that's here. But stay on this one and then check the other one afterwards. So let's just talk about what we have down here for a second. What we have down here is a crude. I don't know the word. It's something I basically whipped up over lunch, a piece of C#, and the only thing it really does is that it has a loop where it's getting something from the keyboard and sending that into Business Central. And we can see there's an endpoint called AL console execute. This is an unbound code unit through OData. So let's go back in and see. So something, let's just make sure that we follow along here. So we type something that gets sent into a function. Let me make sure, function called execute. And let's figure out where's that. Well, that is sitting down here. So let's actually get rid of the thing for a second. And we can see that execute is doing something, and it looks kind of weird. But let's just, for a second, let's talk about. So what we have here, what I have here is, you can call it persistent memory, or you can call it all sort of fancy words. But what this thing is actually doing is that when, and let me go back here. So when I'm establishing the connection, a session inside Business Central on the server, a background session is created. So you can see that I have a function called InitSession, which this guy starts by calling. InitSession calls into this guy. So the first thing that happens is that we call a function called start new worker, and new worker is creating a session, a background session in Business Central, and we're assigning, creating a worker ID as a GUID and assigning that into the worker session. So the worker session knows who that session is, and stuff like that. So as soon as the console starts, calls the web service, request a session. So let's look at the session. So the session is actually a code unit called worker here, and there, that's 107 lines of code. So it's not because there's lots of code in this to begin with. So we got an on-run trigger, of course, in the code unit, and you can see that this code unit has a while true do begin. So there's a main loop that just keeps running. At the end of the loop, there's a sleep 1, meaning that don't just take all resources away. Let other threads on the server have a chance to execute also, and this perhaps should be sleep 10 or sleep whatever. Sleep 1 works right now, and then it does something with a variable called R. R, the set range, set filter, R open, R read. So what is R? Well, R is a query, and the query, let's take a look at that one, is a very simple query. It just grabs data from a table called thread task. I think we can find that. That's probably here, which is as vanilla as they come kind of table. Work ID, a timestamp, an ID, and some code. But hang on, let's get back to the query. So the interesting part here is this read uncommitted. So whenever we're accessing data in Business Central through AL, we always read committed data. But if you remember my little little game here where I modified, and then I talked, as I usually do, and then at some point I also committed. So clearly we had, uncommitted data sitting. We it's not like that whatever is can just say, okay, I'm gonna commit after every command, and then we're good. There's no commit until I do a commit here. So the worker will read uncommitted. Actually, and this part could be committed because this is actually not written by the worker. But anyway, sorry, stay with me. This will make sense in a second. So we read a command, some AL code, and we will end up executing that. So what does execute do? Execute will do the same thing that it did in the other video. I think this is pretty much just I copied the code from the other one. So it will compile. Let's find the good one. It will compile here, and then if there's no error, then it will run. But you can see here that I have a record called result, and result is just another table. And you can see that this kind of looks the same as the request table, apart from the fact that it's the same primary code, but now we have a result field and we have something completed and with arrows. So when the web service has added the task, so add tasks, you see the add task would write down into the request table, the task table, that will then get read by the worker uncommitted. Then we have another query here, read result, exact same thing, read uncommitted. So now the web service will start reading uncommitted data from that table with that very specific, it has to be this worker and this task has to be completed. So we keep looping and reading that until we get a result. Maybe you should have a sleep in here. I actually don't think that's necessary, but could be. So now we're reading the uncommitted result. So even though we might end up in the worker in something that's error and roll back, we're still able to read those intermittent results for each request here, no matter what the transaction state is. So and when the web service finds a record, well, it grabs the result and sends that back to the to whoever is on the other end of the web service. And well, if this takes longer than this is a very crude timeout, so it takes longer than 60,000 loops, then we say, hey, we got a timeout on the reply. So one thing I did this code. Actually, I played around with the whole queries and uncommitted a couple of weeks ago, and sometimes it worked and sometimes it didn't work, and it had me stumped until yesterday. I was out playing a concert and then suddenly it hit me, hang on, bulk insert. So what the reason why I couldn't get it to work for a while, if you notice here at the end that the result record, I say if result.insert then, but there will never be, there will never be another record of the same with the same primary key, so it shouldn't be we should not need to protect the insert, but by adding the if around the insert, then we're not triggering bulk inserts. So let me actually grab browser, and if we do Business Central bulk insert, just to be clear, we find that in the documentation. So the idea, what Business Central will do if you do a lot of inserts and they're unprotected, insert, is that it will kind of bulk insert them on a SQL base. So it will buffer them together in big insert statement instead of singular insert statements. But very correctly specified in the documentation, saying that as if the insert is encapsulated into something that checks for the result of this, then bulk insert will not trigger. And as soon as I realized that while playing, and said, that has to be it. And yeah, and then everything suddenly worked. So the whole tricky, and right now I'm using this trick for, creating persistency between web service calls in order to have my state of variables and transactions and all that stuff. But you could use the same method for tons of other things. I was actually considering naming the video after this, but I think it got too weird, so I didn't. Clearly. But the idea is that you do something that initializes a session, and then you communicate with the session. What would be ultra cool would, of course, if Microsoft at some point would give us proper way of doing inter-thread communication, semaphores to signals and stuff like that. But right now, the only inter-session means of communication we have, at least in the cloud, is the database. If we're on-prem, then we can actually use .NET and Reflection to do some pretty nasty things where we create a static entity that's thread safe, but all session can access it. But that's nasty, and only on-prem, and only with a ton of .NET. Anyway, so here the only option we have at this point is the database, and because we can use read uncommitted, then we can actually use the database to communicate, no matter if the result would end up in something going in error and getting rolled back. So to repeat, we have a component inside VS Code. It's running, it's a .NET component that the only thing it will do is take a string, send it into the web service. And now you can see that I got a timeout, because what I did at some point, in order not to have sessions running forever, is that if we find out we are already in the worker, going up to the top of the worker, just define a time of 5 minutes and saying, okay, if nothing has happened for 5 minutes, and clearly now I talked for more than 5 minutes, then we get a session timeout, and it will just recreate a new session. So if I do list now, I don't have any variables, because those were sitting in the old session, and the old session is dead. So I could go again and say, now I want to create a vendor, and I want to do find first here, and then let's see what this vendor is named. So I think that's pretty cool. So that's kind of interactive AL inside Visual Studio Code. And as you can hear, right now this is a proof of concept. The code is written, tons of stuff is hard coded, but it kind of works, and it actually works better than I expected. It seems reliable. Seems to be fast. No, just to be clear, my AL compiler interpreter is dead slow because everything is AL. So we've got AL interpreting AL. So hundreds of lines of code running to run one line of code. But it's very flexible and gives a lot of neat features. So I think the next step is to kind of support some sort of snippets sitting in a .snippet folder in your project, where you can have small pieces of code that you sitting in VS Code that you will load into this guy and execute in your AL terminal. Anyway, let me know in the comments below if this is still a pipe dream or madness. Let me know what you think, and I read all comments and I reply to all of them that have questions that needs replying to. Anyway, have fun, and I will see you in the next video. Take care. Bye.